Welcome to my YouTube channel. Today, we will discuss some of the most common and important interview questions for full-stack developers. This video is created after deep research, gathering insights from both candidates and interviewers to help you prepare better. Let's start. One of the most common questions interviewers ask is, what different technologies have you used for full-stack development? This is often an icebreaker question, helping interviewers understand your experience across different technologies. They want to see how comfortable you are with various stacks and tools. To answer this effectively, make sure to mention the front-end technologies you've worked with, React.js, Vue.js, Angular, etc., the back-end frameworks you've used, Node.js, Django, FastAPI, etc., the databases and cloud services you have experience with, PostgreSQL, MongoDB, AWS, etc., any additional DevOps tools or CI/CD pipelines you've handled, Docker, Kubernetes, Jenkins, etc. Now let's look at a sample answer that you can modify based on your experience. I have worked with various technologies across the stack. On the front end, I have experience with React.js, Vue.js, TypeScript, and Tailwind CSS. For the back end, I have used Node.js with Express and Nest.js, as well as Python with Django and Flask. I have also worked with Go. In terms of databases, I have used PostgreSQL, MySQL, SQL, MongoDB, and Redis, NoSQL. On the DevOps and deployment side, I have exposure to Docker, Kubernetes, AWS, GCP, and CI/CD tools like GitHub Actions and Jenkins. Remember, the key is to tailor your answer based on your own experience and highlight the technologies you are most comfortable with. I hope this helps. Stay tuned for the next question in this series, and don't forget to like, subscribe, and hit the bell icon for more interview preparation tips. All right, time for the next question. But first, let me ask you, have you ever locked yourself out of your own account? Be honest. Maybe you forgot your password, mistyped it 100 times, and then got the dreaded too many failed attempts. Try again in 24 hours. Well, authentication and authorization are all about making sure that doesn't happen to legit users while keeping the bad guys out. Next interview question. How do you handle authentication and authorization in a full-stack application? Now, if you don't want to look like a deer in headlights during your interview, here's a structured way to answer this. Step 1. Authentication, the bouncer at the club. JWT JSON Web Token for stateless authentication, like a VIP wristband that lets you enter without checking your ID every time. OAuth 2.0 for third-party logins, Google, Facebook, GitHub, because sometimes it's easier to let someone else vouch for you. Bcrypt hashing to secure passwords, because storing passwords in plain text is like leaving your front door open with a neon rob me sign. Step 2. Authorization. Who gets into the VIP lounge? Role-based access control. Some users get into VIP, some stay in general admission. Middleware, Django. Extra security checks before letting someone enter restricted routes. Attribute-based access control. Fine-grained control over permissions, e.g., only managers can approve payments. Step 3. Security enhancements. Because hackers never sleep. Enable HTTP-only secure cookies to keep session data safe. Use CSRF tokens, so sneaky hackers can't trick users into unwanted actions. Rate limiting and multi-factor authentication, MFA, because if someone's trying 10,000 passwords in a minute, they probably shouldn't be logging in. These strategies ensure that only the right people get in and stay in while keeping your app secure and scalable. Quick pro tip for interviews. When answering this question, don't just list these methods. Explain how you've implemented them in a real project. Now let's move to the next question. But before that, tell me in the comments, what's the worst password you've ever seen someone use? If it's password 123, we need to have a serious talk. Next question. How do you handle API versioning in a full-stack application? Before we jump into this, let's be real. Have you ever updated an app only to realize your favorite feature is suddenly missing? Or even worse, your whole app just crashes. API versioning exists to stop that chaos from happening. Imagine you're running a coffee shop. One day, you decide to change the menu, but your regulars still want their usual orders. You need a way to serve both old and new customers without causing a riot. That's exactly why API versioning is important. Now, here's a structured way to answer this in an interview. Step 1, URL versioning, the classic approach. Chloe API and Slack users, first version. API v2 users, new version with updates. Think of it as a new edition of a book. The old version still exists, but now there's a new one with more features. Query parameter versioning, the flexible option. /users 1.0, like asking for a custom order, give me the version I like. 3. Header versioning, the invisible upgrade. Clients specify the API version in request headers. Works like a secret handshake. Only those who know the header get access to specific versions. 4. Semantic versioning, handling updates smoothly. Uses v1.0, v2.0, etc. to distinguish major, minor, and patch updates. Example 1.0 initial release, 1.10 minor feature added, 2.0 major breaking changes. 5. Deprecation strategy. Avoid breaking old clients. Provide clear API documentation. Announce version sunsetting ahead of time. Give adequate migration time. Think of it like Netflix removing your favorite show. They at least warn you first. Pro tip for interviews. Don't just list these methods. Explain when to use each one based on the project requirements. Now, let's keep the conversation going. Tell me in the comments, have you ever had an app break because of a bad update? What was your worst experience? Question. How do you ensure the performance of a web application? Let's be honest, no one likes a slow website. If a page takes too long to load, most users will rage quit faster than you can say refresh. So how do we make sure web applications run fast and smooth? Here's how to answer this. 1. Front-end optimization, faster loading pages. Lazy loading and code splitting to reduce initial load time. Use CDN for faster asset delivery. Optimize images with WebP and compression. 2. Backend optimization, efficient API responses. Use caching, Redis, Memcache to reduce database load. Optimize API responses with pagination and filtering. Use asynchronous processing, background jobs, message queues. 3. Database optimization, speed up queries. Indexing and optimize queries to prevent slow lookups. Use read replicas and sharding for scalability. Avoid N+1 query issues with ORM optimizations. 4. Monitoring and testing. Stay ahead of issues. Use Lighthouse Web Page Test for front-end performance analysis. Monitor with APM tools, Datadog, Prometheus, New Relic. Pro tip. In an interview, mention a real-world scenario where you optimized performance. It shows hands-on experience. Now tell me in the comments, what's the slowest website you've ever used? Let's move to the next question. How do you implement microservices communication? Imagine a rock band. Each member microservice plays their own instrument but still needs to stay in sync. How do they communicate? That's exactly how microservices work. Here's how you can break it down in an interview. 1. Synchronous communication. Direct calls. REST APIs or gRPC for real-time interaction. Works well for services that need instant responses. 2. Asynchronous communication, event-driven. Message brokers, Kafka, RabbitMQ, SQS for handling tasks in the background. Great for decoupling services and handling high loads. 3. Reliability mechanisms, keeping things running. Circuit breakers, Resilience4j, Hystrix, to prevent failures from cascading. Service discovery, Consul Eureka, to manage dynamic service registration. Pro tip, always mention when to use each approach based on real-world scenarios. Now tell me, have you ever waited forever for a website to load only to see a service unavailable error? Let's discuss in the comments. Next question, how do you manage front-end and back-end communication efficiently? Let's be real, front-end and back-end sometimes fight like siblings. One sends too many requests, the other responds too slowly, and the user is stuck watching a spinning loader forever. So, how do we make them communicate efficiently? Here's how you can answer this. Optimize API calls. Use GraphQL to fetch only the required data. Implement batching and debouncing to reduce excessive requests. 2. Improve performance. Cache frequently used data with React Query or SWR. Use server-side rendering, Next.js, Nuxt.js, to load content faster. 3. reduce latency and network overload, minimize redundant requests and compress API responses, use WebSockets for real-time updates instead of polling. Pro tip, show that you understand when to use REST versus GraphQL and how to balance efficiency. Next question, how do you optimize SQL queries for performance? You know that feeling when you order food and it takes forever to arrive? That's exactly how users feel when your SQL queries run slower than a dial-up internet connection. So, how do we make our database queries lightning fast? Here's how you can structure your answer. 1. Analyze before you optimize. Use explain analyze. Think of it like checking Google Maps before hitting the road. You see where the bottlenecks are. Find slow queries using performance monitoring tools, MySQL Slow Query Log, PostgreSQL pgstat statements. 2. Smart indexing. The VIP pass. Index frequently queried columns. It's like giving your database a fast-track lane. Use btree, hash, and composite indexes for efficient lookups. Make sure join operations use indexed foreign keys, or your query will feel like it's taking the scenic route. 3. Optimize the queries. Less is more. Never use select. Only fetch the columns you need. Nobody likes TMI, too much information, and your database doesn't either. Implement pagination, limited offset for large result sets. Asking the database for give me everything is a recipe for disaster. Use prepared statements to avoid SQL injection and improve execution speed. Reduce database load. Work smarter, not harder. Caching, Redis, memcached. Why ask the same question repeatedly when you can just remember the answer? Denormalization. Sometimes combining tables reduces expensive joins and improves read speed. Database scaling. Because one server can't handle everything, use read replicas to distribute query load. Implement sharding for massive data sets. Pro tip, share a story in your interview about how you optimized a slow query. Nothing impresses more than real-world experience. Next question, how do you handle file uploads in a full-stack application? File uploads, the one thing that seems simple until someone tries to upload a 5 GB cat video to your app. So how do we handle uploads efficiently without crashing everything? Here's how you can answer. Where to store files? Cloud storage, AWS S3, Google Cloud Storage, Azure Blob Storage, because databases are not your personal hard drive. Use a CDN for faster file delivery and reduce server load. 2. Uploading files securely. Use pre-signed URLs so clients can upload directly to storage. No need to overload your backend. Limit file size and type, MIME type validation, to prevent accidental malware uploads. 3. Handling large files without pain. Use background processing, Celery, Sidekick, SQS to avoid blocking requests. Implement chunked uploads to handle large files without killing your server. Hash 4. Extra optimizations. Use WebP or compression for image uploads. Implement rate limiting so one user doesn't flood your storage. Final words, thanks for watching. And that's a wrap. We've covered some of the most important interview questions that will help you ace your full-stack developer interviews. If you found this video helpful, drop a comment and let me know which question challenged you the most. Also, let me know what other interview topics you'd like me to cover. We've put in a lot of research to bring you these valuable questions, so support us by subscribing to the channel. Hit that subscribe button and turn on notifications so you don't miss any future videos in this interview series. Stay tuned for the next one, and best of luck with your interviews.